Hello everyone, welcome to today's webcast. My name is Marcin Kubacki and today with Jarek from Red Hat we are going to discuss Quarkus. So what is it?
Hello, Quarkus is a Kubernetes Native Java stack which has been built to optimize the resource consumption of Java applications running in containerized environments managed by Kubernetes or Red Hat OpenShift.
Okay, Jarek, tell a few words about yourself maybe.
Yes, so I'm solution architect. I work for almost 7 years for Red Hat. I'm focusing mostly on the application platform, so specifically OpenShift container platform and also Red Hat JBoss middleware portfolio.
And my name is Marcin Kubacki, I'm Chief Software Architect. I have background in virtualization infrastructure in general, but I also have skills in coding and basically software development. So maybe let's start with the reason why we are even talking about Quarkus.
Yeah, so as you probably know, Java programming language has been created and designed many years before the containers technology has been created. And one of the key principles of Java was to give you a lot of flexibility in terms of how you start your application. And this means that there is a lot of processing done when you start a Java application. On the other hand, if you think about containers, they are built with the immutable principle. So this means that we don't want containers to do any heavy start processing. We want containers to just start quickly and fast. And these two concepts are kind of opposite. And basically the idea of and this is how we can now compare the size of the application that is developed in Java and has been containerized compared to other technologies like Node.js or Go. And these are basically the main reasons why Quarkus stack has been created. So we want to have a possibility to create and build containers which are running Java applications which can start very fast and will consume much fewer resources, especially the RAM memory than traditional Java applications. And in Quarkus, this also means that we have a possibility even to build a kind of images where Java JVM, traditional JVM is not present, is compiled into a native code. And that's the goal. So with Quarkus, with the same Java code built and compiled, we want to consume much fewer resources than with traditional cloud native Java stack.
Okay, so maybe if you could give us some few common typical use cases when you are using Quarkus with Kubernetes.
Yeah, so yeah, in fact the first use case is to run containers in cloud native world managed by Kubernetes. This kind of requires or favors possibility to start containers quickly because they are managed by Kubernetes, and to be able to increase the density of those containers, so to run as much containers as possible on the same infrastructure. Also, there are other use cases, so microservices based applications where we want to have some lightweight containers running our services, or serverless architectures where we need to have a ability to start fast the container based on the events that are generated by the clients that are calling our services.
Okay, and what are key benefits of using Quarkus?
Yeah, so there are some, quite some. So first of all, the Quarkus stack has been built with developer in mind, and this means that we don't want to enforce developers. First of all, we don't want developers to change the way they work with Java. And secondly, Quarkus offers a feature called live coding, which allows you to apply and run very quickly the changes in the code that you are executing. I will show you that feature later during the demo. The other benefit, so Quarkus is called supersonic and subatomic Java. So supersonic means that you can just run your Quarkus application, start your Quarkus application super fast compared to traditional Java stack, as you can see here on the picture. And subatomic means that you can really narrow or limit the size of the memory that is consumed by your Java application significantly compared to the traditional stack. So Quarkus also supports different programming approaches, so both the imperative and reactive programming is supported by Quarkus. So if you have experience with some of them, you can easily leverage this experience. And what is also great about Quarkus is that it does not enforce you to use any new or to learn any new Java framework. It leverages the existing frameworks, the most popular frameworks like, for example, Spring or Microprofile or Apache Camel. So you will build your application using this existing well-known to you frameworks, and they will be converted into the Quarkus.
Okay, and how about build process? How does it look like with Quarkus?
Yeah, so build process is so there are two ways how you can build your Quarkus application. So first one is regular Java-based process. So you will use the Java compiler that will generate the Java runnable, so jar, for example, archive. The second approach is when you want to create a native application image. For that, you will use ahead of time native compilation, which will generate for you the native executable that can be executed as a regular Linux application on the operating system. So the concept of ahead of time compilation, which is kind of key to Quarkus, is basically the idea that we move all the processing that is typically done by Java virtual machine at the application startup to the process of compilation. So, for example, things like scanning classes, class paths, parsing config files, and other operations that are typically done at JVM startup are done by the ahead of time compiler. In order to build a native image, we leverage GraalVM. Basically, we leverage two components. So GraalVM compiler, which builds the code, and also Substrate VM, which generates for us the native images. So the native executables that contains the compiled Java applications.
Okay, so I guess we can have a demo right now.
Yeah, so now exactly is the time for a demo. So I will start with something quite simple. So very simple hello world kind of application. And as you can see here, the source code is built using the JAX RS standard. So this is part of microprofile, for example, so pretty much standard framework. What is different here in this program, in this project basically, is we have to use different dependencies. So I'm using here Maven. You have also option to use Gradle. So as you can see, instead of standard JAX RS dependencies, I'm using here some Quarkus dependencies. And this is basically the main difference you will see in you will have in your projects when you will want to use Quarkus Quarkus stack instead of regular Java frameworks. Let's run this code. So again with Maven, there is a Quarkus dev goal that we need to run. This will start for us locally the web service which exposes this REST service I have defined here. So as you can see, it has started. We can call it with curl. We get the response. Now I will make a small modification to this code. So let's add from webcast. I save it, and when I will execute another call, Quarkus detects the change, and this is this live coding feature, and is rebuilding my application so that I get the new response immediately. This or any other Quarkus application can be built, compiled into native image. For that, we have here the native profile. So that profile will execute the GraalVM, which you need to have installed locally, and will build the native executable. I will skip that task and I will now show you how this application looks like in OpenShift. So in containerized Kubernetes environment. So here you can basically compare how much memory is consumed by the native image. So you can see only 46.5 gigabytes compared to the same application that runs with regular JVM, where you can see over 150 megabytes. And this can be compared with pretty much the same service developed using Spring framework, which consumes over 250 megabytes. So you can see that huge difference, almost 10 times, between the native image and the regular Spring-based application. Also, the startup time will be here super fast. So if I delete this pod, you will see that very quickly the new one is starting. And if we go into the logs, you can see that the startup time here was much below 1 second. Yeah, so it was like 26 milliseconds. So it starts super fast. And of course, we can compare that startup time with the startup time of Spring Boot application, which will for sure need a couple of seconds to be up and running. So here you can see it has started, and it took now it has started. it took it at least a couple of seconds. So you can see here the first time here is 43 and here is 46 when it started, and there was some, and actually this is not the old startup time, so probably it was something around 10 seconds. So you can see this this benefits, but of course Quarkus, you can from Quarkus you can benefit not only with such Hello World applications, but also you can build much more advanced applications. So here I have a second example of application which is built using the Camel framework. So this is kind of simple integration application that communicates with some backend web servers, gets some data, does some data transformation, and execute other call to the web server. So not very complex application, but also not that straightforward and easy as Hello World. And again, the difference here from the developer point of view is really all about changing your dependencies from regular Camel framework dependencies to Camel Quarkus dependencies. So this is the change you need to make in your application to get this running. And again, if we look to the OpenShift console, I have this this Camel service running as well. So let's see first. So this is that one. So you can see it takes only 20 almost 24 megabytes. And if you know Camel and the Red Hat Fuse platform, typically you would build that service into the Spring Boot Java application that you would package into the container, and it would for sure consume not 24 megabytes, but most probably around 250 or even more. So we can go into this service. I will kill it quickly so that you can see, or maybe not. Let's have a look on the log, so that you can see here that it is really Camel framework here running on this tiny image, and it executes the regular Camel code. All right, so that's all for the demo. So we can come back.
We can come back a little bit to the presentation. So if you could give us some assets that everyone would like to have, like getting started, some instructions maybe.
Yeah, so so getting started with Quarkus is quite easy. So I would encourage you to have a look on the on this web page, which okay. So let me enter the so Quarkus so code.quarkus.io. This is a page where you can quickly generate some basic or more complicated project that you can import to your IDE and get it run. So here you can choose between Maven and Gradle. You can specify what kind of frameworks would you like to use in your service. So here you can see also what frameworks are supported. So there is quite a large list of different web framework, data frameworks, messaging, reactive, and many more, as you can see. Also Camel is here, so you can select here what kind of what kind of frameworks would you like to use in your project, and then you simply click generate the code, and you got the project source that you can easily import to your developer environment and just running. Here you can see the command I have also executed from my Eclipse IDE to run locally this the service. So there are others as well, other resources. Let me show you here. So some tutorials, getting started guide, so you can learn how to build a native image, how to build a container image containing your application inside. So you can learn from those guides. There are also some nice webcast recorded where you can learn some details. So all of this is available. So if you only type in Quarkus, if you visit just quarkus.io webpage, you will find there a lot of resources.
Thank you for today's session. I hope you enjoyed it. So I believe that Quarkus is one step further into microservices world. So stay tuned.
Thank you. Bye.